This week we're going to be talking about projections and the uncertainty associated with projections. These are learning outcomes, and there is a fun video if you'd like to see that and some other materials. I'm going to drop right down into the presentation. Okay, so the first thing you need to know about the Earth is it is not a sphere. It's an ellipsoid or an oblate spheroid. That's the most fun combination of words. I also refer to it as a squished sphere. In other words, the Earth, you can imagine it as a big bag of lava that is spinning. Okay, and as it spins, it bulges out at the equator because it's spinning about the poles, so the equators bulge. That's the way to think about it. It's not really full of liquid, but the inside of the Earth is plastic. It can squish a little bit because it's hot in there. Talk to geologists, they'll give you a much better definition of that. But the basic idea is that the Earth is squished at the top and the bottom, at the north and the south poles, what we refer to as the top and the bottom. So it's an ellipsoid, it's not a sphere. Now, some of this is important. I'll point out the really important stuff as we go along. That's the first important thing, is the Earth is not a sphere. This is then handled in GIS by having a semi-minor and semi-major axis. This is not as important, but I'm going to mention it, so the background is here for you. And so the major axis is at the equator, and so that number, that axis or the radius of the Earth at the equator, is going to be slightly larger than the minor axis, which goes from the center of the Earth up to the north or south pole. Okay? All right, so there are standard ellipsoids. In other words, we take this semi-major, semi-minor axis, then you can calculate something called flattening or flattening factor. And from that, they have come up with a series of spheroids. So these are approximations of the spheroid or the ellipsoid that represents the Earth. These are big numbers. So there's the equatorial radius, and notice it's a little bit bigger than the polar radius. Okay. Now, it's important to know that there are different ellipsoids, but not super important. What's really important are datums. The datums contain an ellipsoid, and they contain that flattening value. And the datum is what we use and refer to all the time in GIS to represent that shape of the Earth. That's all that's in a datum, is an ellipsoid. So the datum and the ellipsoid are pretty much interchangeable. Okay, common US datums. This is really important. These three datums are really important because you will see them used commonly in the United States. If you work outside the US, they may be using different datums. You will probably see WGS 84 anywhere you go. That's one of the most common ones. I think it's the most common used internationally now. NAD 83 is a North American datum. Okay, and NAD 27 is another North American datum, but it's really old. Unfortunately, a lot of agencies, counties are still using NAD 27. NAD 83 is newer, and it's very close to WGS 84, but NAD 27 is very different. So these are four that are very important for you to know. Sorry, three that are very important to you to know. And the full name, which you'd want to put in your report, would be North American Datum 1927, or North American Datum 1983, or World Geodetic System 1984. But you will commonly see them referred to as NAD 27, NAD 83, and WGS 84. Okay, so this is again something that I don't think is as important because I don't use it as much. Just know that NAD 27 is a local datum, and there are ones that are based for the entire world, and there are ones that are based for local regions. In fact, if you ever work somewhere like Europe that has had surveying going on for a long time, hundreds of years, you will find there's a bunch of different local datums that they're using. Here in the Western United States, surveying hasn't been going on for a super long time, so we're pretty much going to be on these datums. But you will see other ones, some of them even for very small regions. Again, not super important, but the concepts are important. And here's the most important one because you will see this. NAD 83 to NAD 27, there is a datum shift. In other words, if you have data that's in NAD 83, okay, and the data is in NAD 83, and the datum says NAD 83, it will be correct. Like here we've got an aerial shot of the Arcata Plaza. Notice the numbers, okay? if you take that same datum, the same point, and you change its datum to NAD27, it will move. Same coordinate, okay, same point, but because NAD27 and NAD83 are different datums and have different approximations of the shape of the Earth, that moves the points on the surface of the Earth as you change the datum. In other words, the software interprets those points to be in a different location. This is huge. I see this about once a semester. Somebody will bring me a data set that's in the wrong datum. Now, if it was a point in the middle of Arcata Plaza, it's pretty easy to figure out. Change it till the point goes where it's supposed to be. And that happened with radio towers in the area. I was able to fix that pretty quickly. Somebody brings me a data set in the middle of nowhere where there's very little to identify exactly where the points are, and they didn't do a benchmark that was visible and easy to reference. Especially if it's underneath redwood trees, we can't tell. And then they're off by up to 80 meters, which means you probably won't be able to find your research plots. So very important to make sure you have the correct datum matching your data. And then you can see these types of shifts in data sets that have different datums in them. And the really fun part is we are in the worst part of the continental United States for this problem. So this is a map showing the data shift between NAD27 and NAD83. If you were up here near the Great Lakes, it's probably not going to be a big problem. But Humboldt is one of the worst spots in the country for a shift between NAD27 and NAD83. It can be up to 100 meters on this chart. I've seen it be up to 90. I haven't seen 100 yet, but bottom line is you got to keep track of the datums and make sure they're right. All right.